a good jumping off point. I don't know. Oh, nice with the recording, Jim. So how does this work? So you've got your local view of the DAG, as a validator in Casper at any given time, you've got this view of the DAG. And then if you want to go ahead and propose a block, then here's how it goes. You look at your DAG and you apply the ghost rule, just like we've been doing all along. And so the ghost rule gives you basically like one block that is the correct fork choice tip that you're supposed to build off of. And in blockchain Casper, that's the end of the story, right? You've got your parent, you build on it, repeat. In multi-parent Casper or in block DAG Casper, then you're allowed to include other parents. And so this is what I just learned this morning. You still use that same ghost rule. You still get your same parent, just like you do in blockchain Casper. And then the algorithm from there is you take all of the other tips of the DAG. So, maybe the ones that had a little less weight or the ones that turned out not to be where you would build if this were just regular blockchain Casper, and you sort them by how much weight they have. And you go through them from heaviest to lightest, and you include, as you get to them, you include all the ones that are compatible with the ones that are compatible with what you have so far that you're going to build on. So like I've got my main parent, then I look at the next heaviest tip and I say, is it compatible? And if so, I build on it as well. And then I look at the next heaviest and say, is it compatible also? And so that tells me which ones I can use as my many parents.
Oh, that's so interesting.
How come they're not finding the maximum set?
Yeah, I wondered about that too, or the heaviest set, right? Because like if I have my main parent and then the very next one is compatible, but then that's it. It might have been that I could also like use my main parent and then skip the next one and then use like 6 more that were all compatible and summed up to be heavier or something. I wondered that too.
Yeah, what if there's like one block that's incompatible and it just happens to be the next heaviest, so you don't like put anything else as a parent, but everybody else could have been a parent?
Yeah, like they all would have been compatible if not for that one person or one block who spoiled it that happened to be fairly heavy.
Right.
Yeah, that's a good point. So I don't think, we've been pretty like focused on the paper, which I personally I like. Their meeting was very much like, here's the Scala code and how we've implemented this. So that means it wasn't totally clear to me whether they were saying like, this is the good or best or right way to do it versus like, this is a way to do it that we do.
Okay.
Yeah. So I'm not too sure about that.
So I always wondered how, what's the cost of checking that So how much it costs to check if 2 blocks can merge or not?
Yeah, right. Yeah, so you're saying like once I've got my main parent, which I definitely have to do anyway, what's the computational expense of like now seeing, can I also use this second block or this third block or whatever as another parent?
Mm-hmm.
Yeah, that's a good question. I don't even know for sure how you calculate whether they're compatible.
So that's another question I have. That's the thing. I have no one to really ask. So I think it's you check if 2 blocks don't touch the same state, and in a way that means the same channels, maybe.
That makes good sense to me. Like if
definitely combine them.
Oh yeah.
But then again, what's kind of weird is, so let's say all the transactions. So wait, what I was trying to say. Okay, yeah. So we are signing with our wallets, right? The transactions to pay for the transaction. So in a way, because we do that, I don't see the benefit of the purses to make it faster. So the whole idea of using purses was that you can do it parallel, right? They don't necessarily need to touch the same state. But then if it all comes from the same wallet, then I'm not sure if that works. but then again, maybe I really don't understand this part. So it's just me.
Yeah, I definitely don't know RChain's model for how one will pay for a deploy. I know for a while they talked about something called short leash, and I don't really know how that all works.
Okay.
Yeah. So where do you guys want to dive in today? The topics I had thrown out there were we can do a block DAG simulation, or we can talk about this thing that Isaac and I talked about shortly after our last meeting about empty blocks and where they're useful and how to prevent them from cluttering the chain. And then next week we've got Derek coming to talk about Casanova, so I thought maybe we could get ourselves up to speed on Casanova a little bit.
Sweet.
Yeah, I would love that.
Did you mention the empty block stuff to the Casper group?
No, I didn't. I
Okay.
sort of felt like the interloper there, so I didn't say too much, you know.
Yeah,
They've
okay,
been going
okay.
a few times. Yeah, maybe, you know, if I go again, maybe.
Okay, cool.
Are those calls open, or is it just you got the secret invite?
This time I felt like I got the secret invite, but I now that I've been there once, I'll ask. So I heard about it from Kelly, and she was happy to let me come. So I don't know that they'll be totally open. I don't think they want it to get too broad, but I wouldn't be surprised if you know, we people who are known in the community were welcomed.
Yeah. Well, as long as you're going, we can kind of have you as the spy.
This one they recorded too. I don't know if they've recorded the other ones or not.
Right. Okay.
So, yeah.
Cool.
Okay, cool. Does someone want to do some diagramming then, or do you want to start with Casanova right away, or what do you guys want to do?
I'd like to see a block DAG.
Okay.
Were you gonna say Casanova?
Yeah.
Oh, maybe we should let some other people vote then.
What do you want to do, Drawer?
I'm like crazy tired, so my mind is not clear.
Okay.
I'm good with anything.
What do you want to do, Jim?
Yeah, it's Jim's room. Let's let him decide.
Let's do a block DAG until. Oh, there he is. Okay, go ahead.
Yeah, I'm multiplexing here, working on robots. So
Gotcha. Let's do block DAG until 9:25, and we can kind of square that away, and then we'll jump into Casanova.
Cool.
Can anyone volunteer to do some diagramming though? My mouse seems to be kind of messed up today.
Ooh, let's see. How do we do the diagramming again?
We did Google Draw last time. Kvan was recommending some new tool, but I didn't do my homework to try it out in advance. So I feel like maybe,
is that the OmniGraph?
I think it was called Glyphy.
Oh, okay.
Oh, I've heard of that, but I've never used it. Or maybe I was thinking of Giphy.
Yeah, Glyphy. I'll give it a go if no one can, but if anyone wants to try to do a little like block DAG diagram, I guess diagrams. I'm not even sure.
Just do Google space draw. I think it's the first link there.
Nice.
Oh yeah, it's docs.google.com/.
There we go. All right. So, I don't know if we have patience for.
Oh, so yeah, that's.
Yeah.
Oh yeah, somebody else needs to open it at the very least, right?
Yeah. Yeah, and I think
now.
Yeah. Okay. I don't even know if I can stop the share at this point. Zoom got a little.
Oh, Josh, you weren't here, but I'm on my new laptop right now.
Oh, nice. Way to go.
What's up?
Congratulations. That's great.
Yeah, thanks, man. It doesn't seem like the video is working, but that's, another problem for another day.
Oh, let's see here. I'm going to have to jump back in, I think.
There's a Google Doc that has that has edit permissions for everyone.
Oh, perfect. Yeah, this video just doesn't work.
Where did Jesse go?
He said he had to kill his Zoom session for some reason. I'll start drawing this diagram, though. I have a feeling I know where we're going to start. Maybe I don't even need that.
All right. All right, I'm back.
Hey,
My mouse
back.
works much better now if I should be the person. Did anyone get a link or anything?
Yeah, there's one in the chat that everybody has access to.
Oh, nice, nice. Okay, I think that came while I was away.
Oh, did you not get it?
There we go. All right, roger that.
Okay, cool.
All right. Oh, nice. Yeah, this looks great.
That green is terrible.
Oh, this is cool that we can both kind of do it together.
Yeah. Get some weights.
Okie doke. Oh, this is interesting. Oh yeah, we're gonna have to have a way to show which blocks are compatible with one another, and I think we might have invented notation for that.
Ooh, all right.
All right, cool. So let's say there's B1. So we've got to, how does this normally go again? We've got to decide where does B1 go in the block dag.
Yeah, that's right.
Okay, so I guess right now that's pretty simple. Bob has not seen much. And then I don't have a full complete plan here. So whenever someone thinks they have an idea to demonstrate whatever multi-parent stuff is interesting, we'll give it a go.
Cool. That was interesting. I was watching it on the Google Draw document and getting some lag, but now I'm watching it in Zoom and everything is good.
Oh, nice. That's interesting.
Well, and also stuff would just pop up. I don't see you like moving things around.
Yeah, yeah. So, oh, maybe those work. So, Okay, so then we have to ask ourselves, like, where does B2 go over here in the block DAG view, right? So
Yeah.
in fact, let's even say, I don't know when this gets interesting, but let's say like Claire has seen Bob's block here.
Yeah, okay.
So, oh, in that case, no, that makes it less interesting because in that case, she just builds off of B2, just like always. So maybe this is what happens. So we've got a regular old fork in the block DAG.
Yeah.
And then let's say maybe Bob will build one. This is B3. And he'll build it. He's only seen his own, so he'll build it over here like this. Okay, here we go. Now something interesting is happening. So let's say that Alice builds one next. And then let's just say that like she's seen a lot of stuff. She's seen some things, man. All right, something like that.
Yeah.
So, oh, weird. That didn't get Jeremy would have a key shortcut to make
Yeah,
that.
I thought he said you have to use the arrow thing. Oh, no, that worked. All right, great.
Okay. Oh, I got a double-ended arrow here.
No.
Ain't nobody got time for that.
Oh, wait, why is there's like a cycle on the box? That box has, yeah, there we go. Okay.
That was close. That was tricky.
Anymore.
Okay. So now the question, I guess, is, well, we should draw this. Just kind of means she's seen the Genesis block. So the question is, where does Alice want to put this thing? This is B4 now on the block DAG.
Right.
So the old rule was we go through and we score all of these things, and then she builds on whichever one has the heaviest score according to Ghost.
Right.
So I think we can still do that.
Yeah.
And this is a process that I don't always fully remember. So do we start at Genesis or we start down here at the leaves?
I think we said we start at the leaves.
Okay. So B3 is just Bob, right?
Yeah, just Bob.
So Bob gives this 4.
4, yep.
And then let's see if I can.
Yeah, basically same story with the next one too, because he's the only one that proposed it.
Oh yeah, okay, that's right.
And
yeah, that's why we started the leaves, because they just sum as we go up.
Yeah.
Okay. So then B2, this is really similar, but this one's a Claire block, right? So.
Yeah, so 3. Yep.
Okay, and then the Genesis block, they've both built on actually. So
7
it gets
so far.
7.
Yeah.
All right. So that looks pretty good. So then the question is, oh yeah, right. So then Alice traverses, now that it's scored, now she traverses it starting from Genesis, and she says, okay, well, here's a fork. Well, we go whichever way's heavier. That's down to here. There's no fork, so we definitely go down to here. So I think Alice can say that B3 is her main parent.
Yeah, okay. And that would be the only parent if it were blockchain.
Yeah, that's right.
Okay.
Oh, in fact, I wonder if we can show that with no, that's not what I wanted to do. Curious. Yeah, this looks good. So main parents are going to be shown with 3-point arrows, with heavy arrows.
Yeah, okay.
So then what we needed, so okay, fine. So far everything has been exactly the same as blockchain Casper, right? So now the question is, can Alice also include, she doesn't need to include the Genesis block as a separate parent because it's already an ancestor, right? She's descended it through Bob's chain here. But the question is, can she also include Claire's block? And then, so we have to know, like, are they compatible? So Dror, you gave a pretty good rundown on what compatible meant, right?
I mean, don't listen to me. I'm just assuming stuff.
Well, it made
Without-
sense to me. Let's roll with that as our assumption until we find out we're wrong. So how did you describe it again?
Well, I guess if so, in our chain, right? In our chain world, we're getting the consensus is about couple space.
Mm-hmm.
So if we don't have the same channels, right?
Mm-hmm.
In those, if it's separate channels in the two blocks, I guess we can definitely merge them.
That makes sense to me too. So, like for example, if if Alice sends messages on two channels and puts a receive on a third one, and then Claire sends a message on two channels, but they happen to not be any of the same channels that Alice used, then, and as those things reduce, they don't touch any of the same channels, then those should be mergeable blocks. They just, this is, to use Greg's example. Yeah, go ahead.
I mean, maybe RChain is more sophisticated than that, and they can merge more cases, but
definitely at least those ones can be merged, though, right? Yeah. So to use Greg's example, this might be like one person buying lunch in Seattle and another person buying coffee over in Shanghai. Like they almost definitely don't. Most transactions don't overlap, and so if we have that case, then we can build off of them. Or like in Bitcoin, this might be like, Claire made some payments up here and Alice made different payments down here. As long as none of those payments are double spends of each other or, double spends of subsequent transaction outputs, then those should be compatible. And so we were proposing that maybe we could indicate these things are compatible by like putting the same little shape on both of their arrows here.
Yeah, and kind of the way that Dror described it too, like if the people that are involved in those transactions are totally different, right? Different channels or names or whatever, then certainly we could combine all of them together, right?
Totally.
How this works for bundled channels?
For bundled channels, okay. So bundled means you might have some. Yeah, go ahead.
I mean, you don't know what is exactly the code inside, right? Or channel involved, or I'm missing something.
That's right. So we could have some Rolang code. This isn't going to be too complicated or anything, but we could have some Rolang code that's like, if we send on a particular channel, we want to send we could send something easy like just that process, but you're asking about like if we send a bundle, and so the bundle is like here, let's do this, new X and Y in here. So X and Y are unforgeable names that so far only we have access to, right? And then we send something like star X par star Y. So this thing in here is a process. And then what putting it in a bundle does, it means that whoever receives it, like if maybe over here we've got someone listening on @nil. So for now we'll just say listening for whatever on @nil. Then they do whatever they do. And so I think what the bundle does means like I can call that D or X or whatever I want to. Well, X is confusing, but I can call this thing that I receive whatever I want to call it, but what I can't do is something like destructure it through pattern matching. Like I can't pull back out the individual X and the individual Y. Does that seem like?
But theoretically, they're not secret. You can see it, but right?
Yeah, that's right. They're not secret in the same way that, I mean, they were never secret to begin with, right? You can read their IDs off the blockchain, but what you can't do is obtain the actual channel to like send or receive on.
So that's kind of like unforgeable names, right? I mean, you can see it on the blockchain, but you just can't really interact with it much. Or yeah, you don't have the same capabilities as someone who created it, I guess.
Yeah, and so I think the reason is like, this might be useful because, so here I am up here doing the creating of these things. So I might have like something that listens for messages on X and does something. And then, you know, maybe I also have something that listens on Y. And then maybe I also have something that listens on, and this is the interesting one, on X par Y. Sorry, that's bad syntax. There we go. And the reason to send the bundle here is because this, maybe let's say like this guy is public. I want anyone to be able to call this thing, and so they need this name X par Y, and so I sent it to them. But this one is private, and this one is also private, and so I can't have. If I send this without the bundle, then whoever's receiving it can use pattern matching to get A and B, and then they'll be able to call these private ones. So that's a little, I guess, a little dive into Rolang. So Tomislav, what was your?
Sorry for
that's okay.
But you're saying that bundle only means you cannot. This is not the correct. It's not correct code that you reference this X and Y. This is like a bundle protects you from reference to
exactly. Protects it from destructuring. This is a no user serviceable parts inside, right? Like don't open this thing up and mess with it.
Okay. So it's not something protected to, you cannot see it or something. It's just like a regular syntax that you're not allowed to do this.
Yeah, exactly. And you know, if we wanted to talk about Rolang, there's 1,000 cool things we could talk about with bundles. But I think in terms of Casper, you know, this is a channel just like any other channel, and we can see, you know, like, does this block and this block have, you know, do they touch that same channel, whether it's bundled or not? I don't think it changes the way it works for Casper.
Okay. Thanks. You're explaining.
Oh, yeah. And, you know, same disclaimer Dror gave. Like, that's my best understanding. It might be wrong. So, okay. So I think at this point, like, I tried to, in this cheesy way, show that these are compatible by giving them the same little symbol there. So what that means is we can wire this thing up like that. And then this one's not bold because this is no longer a main parent. It's just another parent. It's a step parent.
Is it different in the code? Can you see? Does it matter?
That's a good question.
Yeah,
I don't know the answer to that.
In terms of like ordering or something, but yeah, I don't know.
Because either way, B4 will be the fork choice.
Oh, you know, so that's another interesting idea. Like I had described this, and I'm sure this part's right. I had described it as like, the way it's implemented is you find your main parent and then you build off of it and other compatible stuff. But like that topic that came up earlier is relevant even right away. Like, so maybe I find my main parent and it's not compatible with anything, but there's like 6 other valid tips. So like here, there was only one other tip, right? But you could imagine like Dave and Eddie and Frank all have, you know, blocks over here. Maybe they're all compatible with one another, but not compatible with B3. Like it would have been nice if I had built off of all those other ones combined.
Oh yeah, like what if the weight of all of those other ones is in some more than the weight of the choice that you're supposed to make from, you know, the ghost rule or something.
Yeah.
And they're all compatible, and the one you're choosing is not compatible with anything else.
So the trade-off I can think of is you're basically trading. So by having one block that you kind of have better confidence that it will be in the next block, right? You switching it to like, then you're gonna have less confidence until it's finalized.
Mm-hmm.
So you're saying by building off of the main parent,
you might have better prediction of what's going to be in a finalized chain, not chain, DAG.
Yeah, that's an interesting
earlier.
How would that work?
And that's kind of
We're saying that's just because everybody is using the ghost rule, right?
Yeah.
So it tries to help keep the DAG together from early on instead of getting too like spacey, too like.
I mean, you shouldn't trust that, right? But it sounds like when Kent is talking about 100 minutes until blocks getting finalized, no one gonna wait for that, right?
Yeah,
Nobody got time for that. So people will decide, depends on how valuable their transactions are, how long they're gonna wait.
Mm-hmm.
And by having a like kind of more confidence that what should be the fork choice rule based on ghost, like maybe it will kind of accelerate some confidence in blocks before they're finalized. Maybe that's not true. I'm just kind of brainstorming.
That seems like a reasonable hypothesis that isn't, we haven't fully worked through, but yeah, I like that idea. Okay, so should we?
But maybe they chose that. Maybe that's not true, and maybe they chose it just because it's easier to implement.
I wondered about that too. Yeah, like it's easy to code it.
Yeah, there's not some complex game theory behind it. It's just this is what we did, guys.
Yeah. So I modified this a little bit. Maybe we'll talk about this last scenario, and then we'll move to Casanova. So now the scenario is, there's two other validators that both have first blocks, just like Claire's. These three are compatible with one another, but they're not compatible with Bob's. I guess in order for this to be a fully determined problem, I need to score these ones too. So let's just say they all have, whoops. Oh boy. Well, I don't know. Let's just say they all have scores of 3.
Okay.
There we go. Got it. Okay. So now the question is, what do my arrows look like in this scenario?
Mm-hmm. Well, so B10 and B11 are both building off the Genesis as well, right?
Yeah, exactly.
Okay.
Exactly. Get that fully labeled up there. Oh, and I guess those should be heavy arrows. All right, looking good.
All right, cool.
So I guess the reason this is interesting is because it illustrates the scenario where we're saying like the way that it's implemented right now, where you have to build off of your main parent, that gives you only this option, and that should be a dark arrow. But it would maybe be cool if we had this other option where, these three are all compatible with each other. So instead we build off of all 3 of them, because now we have, these sum to be 9 and this one only sum to be 4.
Mm-hmm.
But,
yeah, what would be the main parent in that scenario?
Yeah, right. It almost seems like we'd have to get rid of the notion of main parent, right? Because the ghost rule said it should have been this one.
Yeah, it's interesting too, because like to have 3 blocks like that are all compatible, like they, for all intents and purposes, they're just one block anyways, right? So like they're one block with weight 9 sort of.
Oh,
I guess maybe not, because not everybody has built on top of it, right? So they're I don't know.
I mean, in a lot of practical ways, it's like there were a single block with weight 9, right? By saying they're compatible, we're saying they could have all gone into one block.
Right.
Yeah. Okay, right. So yeah, imagine an alternate universe where instead of our 2 unnamed validators receiving whatever deploys are in here, Claire received all of them and then put all those transactions into B2. And then these guys were just like, yeah, I see that. I'll build empty blocks supporting Claire's work.
Mm-hmm.
Then Claire's block would have been the main parent for Alice's.
Yeah.
Cool. Okay, well, do you want to wrap it there and do some Casanova?
Yeah, that sounds good.
All right, cool. I don't have anything much planned, but I thought maybe we could just pull up the paper and dig through it. Or Tomislav, have you read it? Or anybody want to guide us?
No, I'm just like very, very briefly. So
Okay, same. Dror, have you read
We got
much
to
of
the
it?
disjoint unions before. That's what I remember.
I did skim it through when it got published, and then I read some other stuff about it, but I don't remember much. It's been a while.
All right. Well, where should we start? We could start at the start, or we could just choose a random place. There weren't many diagrams. There's a bunch of code in this one, but no figures.
Yeah, let's start from the start.
All right.
What do they mean by optimistic consensus protocol? I know he said permissioned was like bonding.
Yeah, that's a good question. Let's do this.
I think the optimistic might have been because of they're assuming most transactions don't conflict with each other, but maybe it was for something else.
Oh.
Yeah, that sounds
might-
like a good idea.
yeah.
That's a good idea, Dror.
I mean, again, it's a wild guess because I remember it's one of the assumptions mentioned. I think they also might explain what optimistic means here.
So this is something that's new to me, and I heard Vitalik talk about rounds really briefly. I hardly even remember what it was about, but I think Casanova uses rounds. Like if we're all validators, we all have a specific turn where we're allowed to create a block or something like that.
So
Block is also mentioned.
Casper RChain is doing has the same idea.
Yeah, and Vlad was saying that for performance reasons, this is like.
Oh, really? Oh, we haven't ever talked about that. How does that work?
On his talk, he was showing like a graph when the validators are like sending messages in some order, and you see only like these lines between validators. They're just.
Oh, I remember that figure. Is that so? Are you saying that's like enforced in Casper? Like if I send a message when it's not my turn, then it gets ignored or something?
Vlad was just saying about like for performance reasons, like this is like optimal way. So I just remember that.
Oh, that's cool. I didn't realize that.
So wait, what exactly do you mean by rounds? Because like when I hear rounds, I think of like, okay, round one, like everybody submit your blocks. Round two, now we've decided for round one, like round two, everybody submit your blocks and let's figure it out. Or what exactly do we mean by rounds?
Rounds is like round one, validator one can propose, no one else.
Okay.
And everyone else is expecting to get a block from validator one.
Okay.
And then round two, validator number two, etc.
So wait, are the validators randomly chosen, or like your order is predetermined?
Your order is based on the consensus of who are the validators and what order, in what order they're present. The only problem that needs to be solved in a way is like, how do you time it? So Kent mentioned it's going to be based on a wall clock, which I'm not exactly sure what does that mean, but it might be everyone is synchronized based on NTP or something.
Okay.
But I mean, that sort of starts to make rough sense in a like really nitty gritty way where like, all right, here we are, we've got to cobble something together. Like, let's just all agree on the wall clock time. But how does that work? Like, if we're all validators and I'm malicious and I'm trying to like lie about what time I sent I mean, I think the best we can do is say like my block was sent at such and such a timestamp, right? Like what stops me from sending one late and saying and backdating it and saying like, oh, you just got that, must be network latency.
Well, does it matter? Like if you validator X, right? You can only send something at something and everyone expecting you to send it at that time. So
Okay, that's a good point. Yeah, maybe it doesn't matter.
but I'm also not sure exactly if it's about the time stamping or is it about when people receive it. I have no idea. Also, synchronizing clocks is not an easy issue, even if you're relying on some third party. So it cannot be like really accurate, and maybe the protocol will kind of also help people adjust to become more accurate. I'm not sure.
Yeah, so like when my cell phone knows what time it is, how does that work? Does it just query a trusted third party?
Yeah, that's just probably a server. But is this like a time protocol? Is it NTP, something like that?
Yeah, probably. How does that work? Is that just third party?
That's just crazy. Like, if you want to get into that, that's like apparently like one of the most sophisticated.
Oh
stuff
wow!
out there.
Okay, we would need another whole study group.
That's what I heard like back in uni, that because that was something I was suggesting. Was like the professor was like, "Well, it's not that easy. It's not that accurate and not that easy." But yeah, apparently it's really interesting because like clocks it's really hard to have an accurate clock. And so so it's like another field of.
And you're saying this is complicated on the server side, but on the client side, it's just querying the server for the time.
Yeah, but even if you're querying, it's really hard to get the real time, and people can have different times. So you cannot really build. It's not wise to build really accurate services that rely on time synchronization. So I'm assuming here there's kind of some accuracy threshold.
Yeah.
Or something like that.
Okay. All right.
So
Cool.
the rounds might be bigger than what they're really supposed to be, just because of that.
Okay.
So Casanova emerged from two principal observations. So when I read something like that, I always like to orient myself. Like, wait, so I see the first one is here, but I didn't see the second one anywhere. Maybe it's not till the next page. Oh yeah, here we go. All right, cool. So we've got two paragraphs about the first observation. As a rule, transactions on a blockchain do not conflict. The majority of users don't double spend because they want their transactions to clear quickly. That's true. I've never tried to double spend. Despite this fact, modern consensus protocols spend resources coming to consensus among alternatives on every transaction, regardless of whether or not any conflicting transactions have been seen. So I don't really understand. I definitely get the point that like most of the transactions don't have other like double spends and we need to decide which one's the real one. What I don't quite understand is what they're saying about like normal consensus. Where was it? Modern consensus protocols spend resources coming to consensus among alternatives on every transaction. Like what does that mean? If I send one valid transaction and don't attempt to double spend, what alternatives are there? Oh yeah, regardless of whether any conflicting transactions have been seen.
This means that you don't check every block, is it valid or not?
Okay.
I mean, this just makes me think of, Bitcoin basically. Like everybody is validating every single transaction.
Uh-huh.
So like we're doing a lot of work that, I don't know, other people have already done, I guess, but.
Yeah, okay.
So you're saying you're trusting other validators without you checking everything.
Yeah, it sounds like that's what they're saying.
So you're checking this not every block, but every, I don't know.
I think maybe they explain it later stage. So just right now you need to think about that. Well, they don't check every.
All right.
Oh, on the last sentence, they say conflicting transactions do not delay non-conflicting transactions.
Yeah.
Yeah.
Okay. So I guess it feels like this is where he's just saying statements. Like, here's a thing that's true with no justification. Here's a thing that's true with no justification. And maybe the justification comes later.
Yeah.
Mm-hmm.
All right. So let's see. Classic consensus algorithms are generally not suited to take advantage of this apparent lack of conflict because they make two assumptions that are not true in blockchain. Okay. So just to remember the stack, we're on the first principal observation, which now is describing two
assumptions that are not true in a blockchain context. Yeah, about classical consensus algorithms.
Okay. Producers begin with an initial value v and v, where v is the value domain.
Processors.
Yeah,
processors. Oh.
Yeah, what does that mean exactly?
I guess processors are like the validators or miners of the classical consensus algorithm.
Okay.
But I don't know what it means v and v.
Yeah.
Like we're trying to come to consensus on some little v that's drawn out of a possible big V, and we all just like choose our favorite starting value.
I'm thinking like that.
Okay.
So values v and v are readily forged. I don't know exactly what that means. This assumption is usually implicit in the defenses against Byzantine behavior. Casanova is able to take advantage of the general absence of double spends by removing these two assumptions, I guess.
Yeah.
Okay.
Well, readily forged would have to be like a double spend, right?
When I hear forge, it makes me think that I like fraudulently signed something, or like.
Mm-hmm.
I mean, I don't know if it means like I'm able to convince Tomislav that Isaac's little v is something other than what it really is, or whether it means I'm able to convince you guys that some particular number that's not actually in big V is in big V.
Yeah.
But forged makes me think there's some kind of like deception going on.
Mm-hmm.
Okay, so Casanova's able to take advantage of the general absence of double spends by removing these two assumptions. All right, so what was the first observation again?
It was that double spends don't happen all that often, basically.
Oh yeah, okay. And so then the second one is transactions don't need to be totally ordered.
Yeah, okay.
Partial order will suffice. That's, I think, familiar to us from Casper.
Yeah, definitely.
Current blockchains record transactions in a single chain, leading a total order between all transactions. Unrelated transactions don't need to be ordered, only related ones. Okay, yeah. Casanova's able to allow each validator. Okay, so this is interesting. Casanova's able to allow each validator to produce blocks at a regular interval, rather than requiring mining or leader election to produce a single block at a regular interval. Oh, so maybe that means like I as a validator get to produce a block every 5 minutes, as opposed to like we're all hashing, hoping that we get to create the one single block that's going to come out these 10 minutes.
Yeah.
Wait, what?
So I'm trying to parse this portion.
Yeah. So there's usually like you need to select someone to propose a block.
Right. Well, in proof of work, that's true, but in proof of stake, I thought, so, I might have learned something new 10 minutes ago, but I thought it was just sort of a free-for-all where everybody's throwing around blocks wherever they feel like it.
So in the practical BFT consensus, I think usually you select a leader. Casper came up and said, well, everyone can just do whatever. Okay, so yeah, so in BFT algorithms, usually you have a leader, he proposes, and that's it. That's finalized, right? And Casper came and say, hey, actually everyone can just propose, and people place bets. They're just like gonna vote on certain blocks, and then whoever gets more than 50% of the votes of the total stake, then that block is finalized. And everyone can see that. So Casper, in a way, is more similar to proof of work. But the traditional BFT algorithms, they usually have a leader selection. So they achieve finalized blocks really, really quickly because you kind of reach consensus as who's proposing. Does that make sense?
So PBFT is like one of these classic algorithms, pre-Nakamoto algorithms that they're talking about?
Yeah, but I'm not sure if they're doing that.
Right.
Because so the idea is you randomly select maybe a group of people or one leader, and he will create the block. But I think in the old days, in the PFT, I think Tendermint is doing that as well, right? You just I know Dfinity does that as well. But basically, you kind of get a subset. Usually, you electing one leader, but before blockchain era, right? You kind of the environment was different. So I'm not sure how things changed with Tendermint.
All right.
But let's read further and see if that's actually, because that doesn't make sense. Because if that means like one Byzantine player can just bring a bad block, right?
Hey, Jor, maybe this is a good time to ask. What's the difference between delegated proof of stake and these leader elections? Is it a similar idea or is it totally different?
It's kind of similar in a way, but let me think for a second how EOS does things. I'll get back to you later when I review EOS again. I totally forgot.
All right. To achieve liveness, we assume partial synchrony. Oh, this is an interesting thing, which is that the network delivers any message within some finite time bound t. We do not need to know or even have an delta. We do not need to know or even have an estimate of delta at any point. To achieve safety, on the other hand, our network can be totally asynchronous. Messages can be arbitrarily dropped, reordered, or duplicated. So I think maybe this is like, they were criticizing Casper CBC for not being live or not having a proof of liveness, and so they needed to make this like assumption, and then they can prove liveness. So they're saying like, we're not saying delta's 5 minutes or 10 minutes or a year or a decade or anything. There's just some delta that exists. We don't care what it is. We don't need to know what it is. But if it exists, then our proof works. That's kind of how I was taking that.
Mm-hmm. They're making some assumptions about time, right? This is because this is why it's partial synchrony, not partial asynchrony.
So I wonder, like, it's cool to say this, but I wonder how, like, in practice that's enforceable. Like, what, if I send a message and for whatever reason it doesn't get to Bob, like, how do we guarantee that Bob later gets it?
Yeah, this means that we have some kind of timeout that we can say, okay, I will not wait anymore.
Oh, this is like kicking out lazy validators?
Because I'm thinking that if you make some assumptions about time, you must say something about timeout.
Okay.
You're assuming something that you will receive in some amount of time.
All right, events and transactions. We assume some set of all possible events E. We also assume that E is suitably partitioned into mutually exclusive alternatives, which is written like this for some indexing set I. Some set of all possible events.
What is the event?
Soon they're going to tell us why event is not the same as transaction, but to me it seems like it just means transaction, kind of. But because I don't fully get it.
Yeah.
That's a good. Okay.
But we know that we don't. It's not possible to have asynchronous consensus to be live, right?
To have what kind of consensus?
Asynchronous consensus to be live. We don't have like a proof of that. We cannot prove it.
What was the word before consensus?
Asynchronous consensus.
Oh, gotcha. Yeah, have we proven, or has someone proven that asynchronous with total
asynchronous it is proven that you cannot prove it that will be live.
Okay.
So you must have some kind of partial asynchronous.
Okay. All right. So they're trying to say like each one of these little e's. So again, I definitely have something wrong, but I'm kind of reading this for now as little e is like, Alice pays Bob a Bitcoin. So every possible payment from party A to party B of any amount, because E is like every possible event. So each event E belongs to exactly one of these partitions. Or is that, Isaac, what's the vocab here? What would I call these script E's? Maybe we don't have him anymore. At most, one such event could have occurred. Oh, yeah, right. So I always struggled on this part, too. God, where'd that word go? This word event. Is that referring to like little e or script E? Because it seems super weird to say that at most one payment from Alice to Bob could have occurred.
Is it event maybe collection of transaction?
Maybe, yeah. We call events transaction if there exists some script on it. All right. Well, all right. It's 10 o'clock. Do you want to pause there for the day, and then we can end the recording, and maybe Derek can help us out next week?
I can see how Derek can just explain it in 5 minutes.
God, that would be awesome. That would be really great. Yeah. All right. I think I'm going to kill
It's so funny because also people say Casper is hard to understand, but I think it was just like it was hard to explain on paper. And could probably be explained to people in like 10 minutes.